Hi, my name is Kirsten Romig. I am known locally as the cowgirl botanist that works for the Jornada Experimental Range in southern New Mexico. And I'm also a second-year PhD student with New Mexico State University in the Range Department, and my advisor is Akasha Feist. I hope you all are safe and healthy at home, and I am pleased to give this presentation of hidden biodiversity, how soil seed banks vary across ecological sites and states in the Chihuahuan Desert. Now, as an overview, look at this wonderful landscape of the Chihuahuan Desert. It's a stunning area. I'm going to give a little background, the history of the range, and why we are doing this, the location, study design, why a seed bank study, and results with conclusions. Background and location. Well, the Jornada Experimental Range is located in the northern extent of the Chihuahuan Desert. You can see here with this beige color is the Chihuahuan Desert, which is quite extensive. It reaches farther into Mexico and Texas. Las Cruces itself is where we're located, is close to the Texas border and Mexico. The Jornada Experimental Range is 27 miles north of Las Cruces. It's 780 square kilometers, or around 300 square miles, 190,000 acres. It exceeds elevations of 1,100 meters, or 4,000 feet, and the average annual precipitation is a little less than 250 millimeters, around 9 inches. And we get most of our precipitation in the monsoon season, which is July through September. Now, today we've been dealing with a lot of shrub encroachment. It initially began when the range was started in 1912, because in the latter 1800s we had overgrazing throughout the Jornada Basin, and then some droughts impacted the area. So the range was established to deal with the shrub encroachment. Well, and it's still something we've been struggling with, as many of the Southwest has been, and there's many contributing factors. It's not only cattle grazing and droughts, it's also shifting climatic changes. And land managers address shrub encroachment with shrub removal, and that can be either chemically or physically. And we have multi-agency organizations such as Restore New Mexico that try to address this problem with mixed results. It's not always the desired result come in when you remove a shrub. So, after we remove the shrubs, how do we know what plants will replace them? Enter the Jornada Seed Bank Study. It's the first Chihuahuan Desert Seed Bank Study, and there was a little bit of, on the Jornada Range, a study of the playas and seed that were in the playa, but it only did seed counts. Now, we stratified the seed collection, or the soil collection, with the ecological sites. As you can see, this is a map of the ecological sites of the Jornada Range, and we chose 10 ecological sites. There's around 12, but we removed draws and playas because we didn't want to have an accumulation site that seemed it wouldn't represent our most extent area, which is our sandy soils. And here, the 10 ecological sites are sandy, clay, shallow sandy, limestone hills, loamy hills, sand, deep sand, gravelly loam, and sand hills. As a way to explain how ecological states are in ecological sites, I've made this little table which shows our ecological sites that I first showed you. So ecological sites, they are either grasslands or savannas. Savannas have a natural shrub component to them. So our grasslands are the ecological sites of sandy, shallow sandy, clay, loamy. Our savannas are deep sand, limestone hills, sand hills, gravelly, and gravelly loam. And basically, our coding system works from our references, which is our native grasslands, that's our black grama, those are tuberoses and clay, and that's 100s, that's how it's labeled. And for our savanna types, it's 300s. Now, as we progress to the right, it has more increments of degradation. So then we have our 200s. We have our secondary native grass species that come in. So it would be mesa dropsy that replaces black grama. Then we have shrub-invaded grassland. It's a grassland, but it has about greater than 15% shrub component. Then we have our shrub-dominated in our savannas, which is 500s. Then we have our shrubland woodland. We've lost our understory. Our grasses are gone, and it's just a shrubland. Then we have bare annual 700s. That's very eroded areas. And our exotic invaded. We had only one site with the exotic invaded area, and that was our lemon lovegrass. And some other invasions. So, with our ecological state map, as you can see here, it also gets more segmented. Now, there's 67 individual state codes with 3,062 classified states within those. We try to do replicates of 3 for each ecological site and state combination. And as I mentioned before, sandy areas tend to have a greater range of degradation, so those were sampled more. We collected 308 soil samples. About 258 of these were planted in the greenhouse. And we basically gave it what the most limiting resource in Chihuahuan Desert, which is water, enough water. How we collected the soil was we homogenized from 8 different plant and bare interspaces, and the collections were oriented around a central random point. It came out to about 800 cubic centimeters for each waypoint. This is a little diagram of how we established it. We had the random point in the middle. We made quadrats with the cardinal directions, and then we took from each quadrat interspace collection and then a plant patch collection. A plant patch was not sampled from twice, and the plant patch had to be perennial plant patch that was greater than 20 centimeters, and the interspace had to be bare and greater than 20 centimeters. And this was our state-of-the-art soil collecting implement. Now, the first day in the greenhouse after we collected all the soil samples was October 29th, 2015, and this is what it looked like. It was like a spice market in India. And then 10 months later, this is what it looked like. We had our whole gamut of species that ran through. We started with annuals and then came into our perennials, our grasses, and then eventually we had shrubs. Over the 2-year period, the soil yielded 12,777 seedlings from 175 species of vascular plants and 17 moss species. I'm just taking a subset of those ecological sites because it is a lot of information. There's on the y-axis, if you notice, this is the number of germinable seeds, so germinated seed from the greenhouse that was identified, and per square meter. So this is area covered. And you can see with our shallow sandies and our sandies, what's really remarkable is that they're mostly perennials. A lot of times we think that it would be mostly annuals, but it is mostly perennials in these areas. Here we have cumulative total number of species. So it's species richness above ground versus below ground. Green portions shows where the vegetation that was found at the site where we collected the soil. And the brown portion is what was germinated in the greenhouse. The orange is what is shared, the species shared between the 2 areas, so above ground and below ground. So everything germinated for the clay 100s is this brown portion plus the orange, and the vegetation found at these reference clay sites was the green plus the orange. And what first impressed me with this bar graph was how little species the 2 areas shared. And some areas didn't have shared any species at all, like limestone hills, reference limestone hills. Now, our most species rich was with the 2 together is our loamy 100s. And you would think with the loamy 100s, which is our reference grassland loamy sites, that would be the case. But the next one is our shrub invaded sandy sites. And then we have our degraded deep sand sites, which actually match as far as the amount of species found on above and below ground, the gravelly reference site. We also have our two lowest counts, which is our sandy 900s, which is our Lehman lovegrass exotic invaded state, and then we have our shallow sandy, which is our bare annuals. And if we compare that with the seeds per square meter, so if we're looking just at germinable seed, here's with the shrubland mesquite coppice dunes, which is our deep sand 600. So that's the brown plus the orange of a cumulative number of species found at these areas. We have a lot of seed that is stored within those grass and those coppice dunes. And then if we look at our reference grassy loamy sites, remember how diverse that the species richness was for above and below ground. Here, just the germinal seed, it kind of comes to this midway point. And with our shrub invaded sandy sites, again, we have a large storage capacity of germinal seed, which happen to be mostly perennial. So what does this all mean? Soil seed banks in the Chihuahuan Desert offer an insight into future plant biodiversity and changing climate. Degraded sandy ecological sites act as seed caches, storing seed in optimal conditions as far as it's like an arid and storage component. So the seeds can be kept longer and because there's less moisture are not degraded as in maybe eastern ecological sites. And this is good for future opportune events such as major rainfall years. So with proper management and timing, shrub removal could be facilitated without seeding, and because the seed is there to establish good biodiversity and good habitat. And with that, I would like to acknowledge the many people who helped with this research. And if you have any questions, please email me at kirsten.romig@usda.gov. Thank you for your time.